In this video, we will discuss about union of sets. You know that union of sets contains all the common elements. We have to write all the common elements that are present in both sets or more than one set. Like if we have to write A union B, we have to write the common elements and elements plus the uncommon elements. We have to write both of them, but only once. So let's check out how do we write this whole thing by using examples. Alright. So union set contains all the positive integer less than 10. So A is that and B is this. Show this information on a Venn diagram. Again, we need to draw a rectangle. This is our universal set. Again, we have to look forward towards the common elements in both of the sets. 3, 5. Yeah, that's it. So we have to make that overlapping and write the rest in their own respective sets. 3 and 5, 1, 7, 9. 4 and 6, yeah, that's it. Okay, we do have all of these sets. We have to write less than 10 in this space. 2, 8, yeah, 2 and 8 are the elements that are present there other than A and B sets. Okay, we have done with the A part. B, A union B, we have to write that A union B, as I've already discussed that we have to write all the elements, common and uncommon, but only once. We have to write common elements only one time. So I hope these are all of these that are present in both A and B. So number of A union B will be 6. So this is part B. This A union B is equal to B union A. Yeah, that's obvious that they satisfy this condition. Alright, list A union B complement. So, and what do we do in complement? We have to take that difference between the universal set with the A union B. As you know that A union B contains all of these elements. So rest of the elements that are present in universal set is 2 and 8. So we have to write this like 1, 2, 3, 4, 5, 6, 7, 8, and 9 with the union part. So you know that we are done with that. We have 3, 4, 5. We have to take the difference. So only the left elements are 2 and 8. Alright, so in the last part we have to see A union B, a subset of A or not. Alright, so we have this set A union B over here, and we have to see that is it a subset of A or not. Like if we do right, no, it's not a subset of that because it doesn't contain all of those elements that are present in A. Alright, if we say that A, Alright, a subset must have all of these elements that are present in E. It can contain less or more elements than subset. But subset must have all of these elements that are present in A. Like for example, if we say A set has I'm just giving you another example. 1, 2, 3, 4. All right. And we have this 3 and 4. So we can simply say that B is a subset of A, like this 3, 4, 1, 2. Okay. So 3, 4 can B set contains all the elements that are present in A. So we can simply say that B is a subset. All right. Let's check out another example. Union of sets. Okay. Universal sets contain all triangles. Isosceles triangle represented with the I set are at the right angle triangle. Show this on Venn diagram like this. All triangles are isosceles right angle triangles. So those have same these sides. Like it may be possible that some of these have both I or some are set. We can say that both have some of these set may have I or R set both. This is I set, this is R set. Because in right angle triangle we do have two similar sides and two same angles over here. But we do have the isosceles triangle as well that have both same angles and both same sides, but they may not be right angle triangle. And we do have right angle triangle that which don't have both equal sides. So we just use the overlapping for the common triangles. Okay, sketch a member of I intersection R. Alright, so this will be the sketching of this, like this. I think that will be the sketch of this because the opposite angles will be the same and these two sides will be equal to each other. This will be the sketch of I intersection B, I intersection R. Okay, describe I intersection R inverse C. So what is the description of this? They contain right angle triangles and isosceles triangles both. Right angle triangle and isosceles triangles both. Okay, so what's the D part over here? Describe I intersection R complement. So in this section we have to see the R complement first. So what will be the R complement? That we have all of the triangles. They do have the I section. Like you have to take the difference with the universal set. So this will be the R complement. So in this way we have all of the triangles that may be isosceles but not right angle triangle. All triangles plus isosceles triangles. All right, so our complement will be this. So we have to take the intersection of this with our complement. So you know that in our complement we have the isosceles triangle in. So when we are taking the intersection with isosceles triangle, we will just say that this will be equal to isosceles triangles, because in intersection we do have the common elements. All right, so I hope you are done with the Venn diagrams, union of, and intersection of sets. So this is the whole thing, and it's pretty simple.